Hello, this is Mrs. Nearing, and this video is going to be talking about dimensional analysis and some applications involving combustion and how much energy is released from certain fuels. So this is related to lesson 431, I believe, in our unit here. So let's talk about this type of problem. So we've got some information here in a table. We know we're given information about the substances. These are all the fuels that we've been talking about, and their chemical formulas, their molar masses. These are something that you can find on the periodic table. I just put them there for us to make it go a little bit faster. But the way that you'd find this number from the periodic table, for example, if you had C8H18, is you would take the mass of 8 carbons, which if you look on the periodic table, it's 12.01, and then you would add to that the mass of 18 hydrogens. So you end up getting 114. That's where this number is coming from. And then we have this energy value here. It's the energy release per mole of the fuel that you burn. So one type of question here would be, if you want to produce a certain amount of energy, how many moles of your fuel would you need? So whenever we're setting up this type of problem, the first thing you want to do is write down what you are given in the problem, which in this case, 400 kilojoules is the unit I am given. And then I'm going to want to multiply this number by some ratio. This is something we call the conversion factor. It's a relationship between two units. An example would be there are 60 minutes in 1 hour. That is a relationship that I can use to convert 2 hours into 120 minutes. In this case, I want to know the relationship between energy and moles. So right here, this number tells us that for every 1 mole of octane that we combust, it's going to release 5,430 kilojoules of energy. And then going back to our dimensional analysis strategy, I have a certain unit here that I'm beginning with, and whatever units I have should show up on the bottom of this conversion factor, and the units that I want, which is moles, should show up on the top. So I want to get rid of kilojoules, end up with moles. And then I fill in the numbers by looking at this known relationship here, and I can tell from here that for every 1 mole of octane, you release 5,430 kilojoules of energy. So if you plug that in your calculator, you do it just the way it's written, 400 times 1 divided by 5430, and you end up with 0.074 moles of octane are needed. Okay, how about in this case? This case I'm starting with moles, so I'm starting with 3.2 moles of hexane, and I want to find kilojoules. So since here I'm starting with moles, this time moles is going to be on the bottom of my fraction. So the units that I have go on the bottom, the units that I want go on the top. And this relationship I find from the table up here, so this tells me that every 1 mole of hexane releases 4,160 kilojoules. So 1 mole of hexane is 4,160 kilojoules. So notice in the first problem, the energy was on the bottom. Second problem, energy is on the top. It all depends on what the question is asking for. So the units that you want should go on the top. Okay, and then 3.2 times 4,160 divided by 1, you end up with 13,300 kilojoules. Okay, so that's one type. Let's look at another type of problem. This is just a mole to gram or gram to mole conversion. So I'm going to do what I did before. The first thing I'm going to do is write down the number that I'm given. 50 grams is what I'm given. And I want to convert grams into moles. So now, instead of using this energy value, I want to use this number right here, because this number is the grams per mole. So this number tells me, for example, that 1 mole of octane weighs 114 grams, or 1 mole of hexane weighs 86 grams. So here I'm talking about hexanol. So I want to look at this number, and this number tells me that 1 mole of hexanol weighs 102 grams. So if I plug that in my calculator, 50 times 1 divided by 102, I end up with 0.49 moles of hexanol. All right, this problem, again, first thing I'm going to do is start by writing down the number that I'm given, 4 moles of hexane, and I want to convert moles of hexane to grams. So I'm going to go up here and look at the table, and it looks like 1 mole of hexane weighs 86 grams. So plugging that in, 4 times 86, I end up with 344 grams. Okay, and then see the next video for a few more of these